In this video, we will learn how to factor perfect square trinomials. Recall from multiplying binomials using the FOR method. This particular example. Let's say we have to multiply the binomial x plus y with the binomial x plus y. So we are multiplying two identical binomials. Using the FOR method, let's multiply the first terms, x times x, x squared. The outer terms, x times y, that's plus xy. The inner terms, y times x, that's plus xy. And the last terms, y times y, that's plus y squared. Now this expression can be simplified by adding the second and third terms because they have the same variable. So we get x squared. If you add these two, you get plus 2xy. Okay, and then plus y squared. Now this expression is the general form of perfect square trinomials. Let's examine the terms. The first term is a perfect square. X squared is a perfect square, so it should be positive, always positive. The third term is also a perfect square, so you have here y squared. So since this is a perfect square, it is also always positive. How about the second term? The second term is twice the product of the square roots of the first and third terms. Okay, so we can get the square root of the first term, x squared, so that's x. Square root of the third term, that is y. If we multiply the square roots, that's x times y, so we have xy, and multiply it by 2, that should be the second term of the perfect square trinomial. Based on the above derivation, the factors of a perfect square trinomial consist of two binomials, two identical binomials, in which the terms are the square roots of the first and the third terms in the given trinomial, such that x here is simply the square root of x squared, y here is the square root of y squared. Now the operation in the binomial factors is given by the sign of the second term in the trinomial. Whatever the sign of the second term is, that is the sign or the operation in the binomial factor. Now this expression, since the two binomials are identical, can be simplified by writing the binomial raised to 2. Before we try any problem, let's consider or let's remember the first step in factoring any given expression, and that is to factor out the common monomial factor. In the first example, let's say we have to factor x squared plus 12x plus 36. First question is, do we have a common monomial factor? No, because the coefficient of x squared is only 1. The next question is this trinomial a perfect square trinomial? Let's check. Can we get the square root of x squared? Yes, that is x. Can we get the square root of the third term, 36? Yes, that is 6. Okay, and is the second term twice the product of these two? So let's multiply these two, x times 6, that's 6x. Times 2, you get 12x. Therefore, this is a perfect square trinomial. To factor, we use the square roots of the first and third terms, x and 6. Now, since the second term is positive, we have here plus, and then we raise this binomial to the exponent 2. Second example, let's say we have to factor the trinomial m squared minus 2mn plus n squared. Okay, do we have a common monomial factor? No, because the coefficient of m squared here is 1, is only 1. Okay, the next question is this a perfect square trinomial? Let's check. Can we get the square root of the first term, m squared? Yes, that's m. Can we get the square root of the third term, n squared? Yes, that's n. Next question is this middle or the second term twice the product of the square roots of these square roots. So let's multiply m and n, that's mn, times 2, we get 2mn. Therefore, this is a perfect square trinomial. For the factor, we use the square roots of the first and third term, so we write m and n. Since the second term is is negative, we use minus here, and then we raise the binomial to the exponent 2. Now, how about the trinomial p squared plus 4pq plus 4q squared? Okay, do we have a common monomial factor? No, because the coefficient of p squared here is only 1. Okay, next question is this a perfect square trinomial? Let's check. Can we get the square root of p squared, the first term? Yes, that's p. Can we get the square root of the third term? 4q squared. Square root of 4 is 2. Square root of q squared is q. So we have 2q. Next question. Is this second term twice the product of these two square roots? Okay, if you multiply these two square roots, you have 2 times p times q. So 2pq times 2 for the twice, you get 4pq. Therefore, this is a perfect square trinomial. Okay, to factor, let's use the square roots of the first and third terms. So we have p and 2q. Okay, since the second term is positive, we have here plus, and we raise the binomial to the exponent 2. Fourth example, let's say we have to factor the trinomial 4x squared minus 12xy plus 9y squared. Okay, the first question is, do we have a common monomial factor? No, because 4, 12, and 9 do not have a common number or factor. The next question is this a perfect square trinomial? Let's check. Can we get the square root of 4x squared? Yes, that is square root of 4 is 2, square root of x squared is x, 2x. Can we get the square root of the third term, 9y squared? Yes, the square root of 9 is 3, and the square root of y squared is y, so that's 3y. Okay, next question, is this second term twice the product of the square roots? So if you multiply these square roots, you get 2 times 3, 6, and then xy. So 6xy, twice of that is 12xy. Therefore, this is a perfect square trinomial. To factor, let's use the square roots of the first and last terms or third terms. So we write 2x and 3y. Then, since the second term is negative, we use minus here, and then we raise the binomial to the exponent 2. Lastly, what if we have to factor the trinomial 4a squared plus 4ab plus b squared? Okay, do we have a common monomial factor? No, because the coefficient of this b squared is only 1. Is this a perfect square trinomial? Let's check. Can we get the square root of 4a squared? Yes, the square root of 4 is 2. The square root of a squared is a. Therefore, we have 2a. Can we get the square root of b squared? Yes, that's b. Okay, and is this second term twice the product of these two square roots? Okay, let's multiply these two. 2a times b is 2ab. Twice of that is 4ab. Therefore, this is a perfect square trinomial. To factor, let's use the square roots of the first and third terms. So we write 2a and b. Since the second term is positive, we have here plus, and then we raise the exponent to 2 to the exponent 2, and then we have the factor of this perfect square trinomial. If you have any questions, please leave a comment.